Hello dear students, welcome to Konar classes. In this session, we are going to solve 3 questions on homogeneous differential equations. Okay. The first question, as you see here, it is written, so that the differential equation x cos y by x dy dx equal to y cos y by x plus x is homogeneous, and solve it. So how to approach this one, dear students? So it is given that x cos y by x into dy dx is equal to y cos y by x plus x. What we are going to do? We are going to divide both the sides with x cos y by x. Then what we are going to get? In the left hand side we get dy dx, and the right hand side, once we divide by y cos y by x cos y by x, so we will get y by x, okay, plus x by x cos y by x. X will get cancelled and we will left with 1 by cos y by x, correct? 1 by cos y by x, correct? So we are able to divide both sides by x cos y by x because x cos y by x is not equal to 0, correct? Now if we look into this particular function, this is a homogeneous function of degree 0 in x and y. So what is the step? As you remember, we should make the substitution y equal to vx. Y equal to vx, if we differentiate both sides with respect to x, we are going to get dy dx is equal to v plus x dv dx, correct? Now this value of dy dx we are going to apply in this equation. So what we are going to get? So this implies that v plus x dv dx, this value of dy dx we applied here, is equal to, right hand side is y by x equal to what? V. Y equal to vx, that means y by x equal to v plus 1 by cos y by x, that means 1 by cos v, correct? So if we see, v and v got cancelled, okay? So what we left with? So we left with, this implies x dv dx is equal to 1 by cos v. Now from here, we can come to this part and let's solve. So that means dv cos v into dv is equal to dx by x. Cos v dv is equal to dx by x. Now we will integrate both the sides. What is the integration of cos v dv? That is equal to sin v. Sin v is equal to integration dx by x, that is log mod x, plus 1 integrating constant, that is we can consider this as a c, correct? So this implies what? This implies sin, what is v? V is nothing but y by x. We should apply back the value of v. Y by x is equal to log of mod x plus c. This is the solution to the given differential equation. This is the general solution. Also you can little bit optimized in the sense what? Instead of from here I am going to write it down. So if you see from here, what we can do, we can write, this implies sin v is equal to log of mod x plus 1 integrating constant. That integrating constant, we can, here we wrote c, here we have written that integrating constant as c, here we can write that is equal to log of mod c, for example. If c is an integrating constant, then log of mod c should also be an integrating constant. So why so? So this implies sin v means y by x is equal to log of mod c into x. Okay, so that is also a solution, because we know that log m plus log n is equal to log of m into n. So in this way we get the solution to the same differential equation. Whichever you can apply, you can take this one also or this one also. Okay, so now let's proceed to the next question. Okay, so the next question I'm going to write it down here. And here is the question, dear students. Question is, so that the differential equation (2y into e to the power x by y dx plus y minus 2x into e to the power x by y dy is equal to 0 is homogeneous, and find its particular solution, given that x equal to 0 when y equal to 1. Okay, so let's see how we are going to solve this particular question. So dear students, what we see that the differential equation here it is 2y e to the power x by y dx plus y minus 2x e to the power x by y into dy. So it is x by y. So that gives us a indication that we should replace that entire equation something like this. So we can write from the given differential equation 2y e to the power x by y dx is equal to, right hand side I took it, so it should be 2x e to the power x by y minus y dy. Correct. Now we take this dy in the left hand side and 2y e to the power x by y in the right hand side. So from here what we get, dear students? We get dx dy is equal to 2x e to the power x by y by 2y e to the power x by y. So that will become x by y. Correct. Okay, and here we will get y by 2y e to the power x by y, that becomes minus 1 by 2 into e to the power x by y, and we are going to write it since y into e to the power x by y cannot be equal to 0. Correct? Absolutely clear? Now what we see, dear students, this entire function, what you see in the right hand side, it is a homogeneous function of degree 0 in x and y, because here we can write this is equal to y to the power 0 into a function of x by y, and here it is dx dy. That's why what is the substitution? Substitution here will make x equal to vy. X equal to vy. If you recall that in the previous session I explained this particular case. If dy dx is there, then y equal to vx. If dx dy is there, then x equal to vy. And here what we will do? We will differentiate both sides with respect to y. Then what we are going to get? We are going to get dx dy is equal to v plus y into dv dy. Correct? And this value of dx dy we are going to apply here. Then what we are going to get, dear students? This implies v plus y into dv dy is equal to x by y, that is equal to v minus 1 by 2 into e power x by y, that means 2 into e power v. Correct? And what we see, that v and v got cancelled, and what we will end up with, so that we can write it here. Okay, so from here we come here, so this implies we get y dv by dv dy, y dv dy is equal to minus 1 by 2 into e to the power v. This implies what, dear students? 2 into e power v dv is equal to minus dy by y. Correct? We are going to perform integration, left hand side and right hand side both. Correct? 2 is a constant, so that's why you took it out of the integration. And here also minus 1. So then what we get? We get 2 into e to the power v. Integration of e to the power v is e to the power v is equal to minus log mod y plus 1 integrating constant c. Correct? So from here what we get, dear students? We get 2 into e power x by y, because x equal to vy, so v is equal to x by y, so that value we need to apply back. Okay, so this is equal to minus log mod y plus c. So this is a general solution or primitive, but according to our question we need to find the particular solution. You see here it is written particular solution, given that x equal to 0 when y equal to 1. That means what? So that means we need to apply that x equal to 0 and y equal to 1 in this general solution, and that will help us to find the value of c. After that, that value of c we will apply here to get the particular solution. Correct? So what we do? So from here, if we apply y equal to 1 and x equal to 0 here, 2 into e power 0 by 1 is equal to minus log mod 1 plus c. So log 1 value is 0 and e to the power 0 by 1 means e to the power 0, that is 1. So from here we get the value of c is equal to 2. Now this value of c is equal to 2 we are going to apply here from here. Okay, so what we are going to get? So from here we are going to get 2 into e to the power x by y is equal to 2 minus log of mod y. Correct? Or we can write this thing. This implies 2 into e power x by y plus log of mod y is equal to 2. And this is the required particular solution, as it is not having any arbitrary constant. Okay, this one. Okay, fine, then let's proceed to the next question, that is the last question in this session. Okay, so let me write down the question here, dear students. As I always say, dear students, you also do along with me. You see that I am not doing very fast. Okay, and still if you feel that I am doing it fast, you can pause the video, do at your own pace, and then proceed further, so that when you are watching this video, during that time your learning is complete. Okay, so let me write down the next question. So the question is, so that the family of curves for which the slope of the tangent at any point x comma y on it is x square plus y square divided by 2xy is given by x square minus y square is equal to cx. Okay, let us understand the question first geometrically, and after that we will proceed for the solution. So that the family of curves for which the slope of the tangent at any point x comma y. Whatever I have read so far in this problem statement, let us give a geometrical interpretation or a visual representation. So let us consider these Cartesian coordinates. Okay, so these are the coordinate axes. Now there is a curve. What is that curve? We need to prove, according to the question, the equation of that curve is x square minus y square equal to cx. But let's take the curve is something like this, it is something like this. That curve, we can give that curve is y equal to fx. Okay. Now, according to the question, if we take a particular point x comma y on that curve, and if you draw a tangent, correct? Now, if this tangent makes an angle theta with the positive direction of x-axis, according to the question, then that dy dx is nothing but tan theta, that is called the slope. And according to the question, this dy dx is equal to x square plus y square by 2xy. That is equal to x square plus y square by 2xy. So dear students, from this problem statement, whatever is given, what we are able to interpret that dy dx is equal to x square plus y square divided by 2xy. Correct? Now what is our task? Our task is to solve this differential equation, and as a solution what we are going to get? We are going to get a general solution which is a family of curves, and we need to show that family of curves is something like this: x square minus y square equal to cx. So first of all we need to solve this differential equation. Okay, so how to solve this thing? So from here what we can write, dear students, dy dx is equal to, let's take x square common from the numerator. Then what we are going to get? 1 plus y by x whole square. Correct? And in the denominator also, let's take x square common. What we are going to get then? 2 into y by x correct? Now this x square in the numerator and x square in the denominator will get cancelled. Okay, so from here what we get, dear students, that dy dx is equal to 1 plus y by x whole square divided by 2 into y by x. Since x square is not equal to 0, that's why you are able to cancel both from the numerator and denominator, correct? Now as you see, dear students, that the function in the right hand side, that is its expression 1 plus y by x whole square by 2 into y by x, this is a homogeneous function of degree 0 in x and y. Okay, because this thing can be written as x to the power 0, which is 1 into this entire expression of function of y by x. So now the standard procedure, you are master in this by this time, that we need to make the substitution y equal to vx. Okay, so let's make the substitution y equal to vx from here. Okay, y equal to vx. So this implies, if we differentiate both sides with respect to x, what we are going to get, dy dx is equal to v plus x into dv dx. Now that value of dy dx, which is v plus x into dv dx, we are going to apply it here. So then what we are going to get, that entire differential equation, this entire differential equation, we are going to get something like this, that v plus x into dv dx is equal to 1 plus y by x equal to v. So y by x whole square means 1 plus v square divided by 2 into y by x, that means 2 into v. 2 into v, correct? So from here, sorry, what we are going to get, dear students, that x into dv dx is equal to 1 plus v square divided by 2v minus v, correct? So from here what we get, dear students, that x into dv dx is equal to 1 minus v square divided by 2v, correct? So from here what we get, dear students, so from here we get 2v by v square minus 1 into dv is equal to minus dx by x, correct, multiplied by minus 1. So both in the left hand side and right hand side. Now let's perform the integration of both the sides, correct? Now if we perform the integration, let me do it into the this part. Okay, so I can remove this one. Okay, so now if we proceed here from this part, what we are going to get. So as we see, dear students, that differentiation of the denominator, that is differentiation of v square minus 1 is 2v, which is the numerator. So what we can write? So this implies log of mod v square minus 1 is equal to minus of log of mod x minus of log of mod x plus 1 integrating constant c, correct? So this implies what, dear students? So we need to apply back the value of v. What is v? V is equal to y by x. So this implies log of mod y square by x square minus 1 is equal to minus log of mod x plus c. This implies log of mod y square minus x square divided by x square. Okay. Now this minus log x, we took it in the left hand side, that become plus log mod x. In the right hand side we get c, correct? Okay. Or let's do one thing, as we need to give it here a c and we need to do some adjustment. So let us make it as C1, the integrating constant at C1. So now log of m plus log of n, that is equal to log of m into n. So from here what we can write, dear students, this is equal to log mod y square minus x square divided by x square into x is equal to C1. Correct? So that means what, dear students? So this implies log of mod y square minus x square divided by x is equal to C1. Okay? Since x is not equal to 0. Correct? That's why you are able to cancel. So this gives that y square minus x square divided by x, the mod of this is equal to e power C1. Correct? Correct. So now this implies what? So for that, let's proceed into this part. Okay? I can remove this one. So let me use a different color. So from here we come back to this part. Okay, so this implies what, dear students? That y square minus x square divided by x is equal to plus minus e to the power C1. Correct? So that implies what? That implies x square minus y square is equal to minus plus e to the power C1 into x. Now this minus plus e to the power C1, that we can consider as a new constant C. Why? To show it is in this form. So this implies what? This implies x square minus y square is equal to Cx. This is the required equation of the curve. Okay, the family of curves. Okay, dear students, so I hope you got a very clear idea. So we have done a good amount of questions on homogeneous differential equations in this session and the previous session also, where I solved one question. Now your task is to log into the online test platform at konarkclasses.com and appear for first the DPP, that is daily practice problem, followed by practice test, that is PT, followed by UT, that is unit test, followed by MDT, that is module test, and finally mock test. In this way your preparation is going to be rock solid. Thank you very much. Bye bye.